Okay, GCSE question of the week, week 9. Foundation first. Number 1, work out 2 3/4 minus 1 2/5. Okay, so first of all, to do these questions, we're going to need to convert those mixed numbers into improper fractions. So we'll convert the 2 3/4 into 11 quarters. And how do we get that? Well, the 2 whole ones we're going to convert into quarters, and 4 quarters is a whole one. So 2 whole ones is 2 lots of 4 quarters. 4 quarters plus 4 quarters, that's 8 quarters. Plus the 3/4 gives us 11 quarters. And 1 2/5 we're going to convert to 7/5. How are we going to do that? Well, the whole one we need to convert into fifths, and 1 whole one is 5/5. So we've got the 5/5 plus the 2/5, that gives us 7/5. So we have 11 quarters minus 7/5. 11 quarters minus 7/5. Now we can't subtract those because we need the same denominator. So we'll multiply our 4 and 5 to give us our lowest common multiple of 20. So we're going to convert both of those fractions to 20ths. Okay, now different ways to do this, but we could think, what do we do to the 4 to get 20? We multiply by 5. So we better multiply the numerator by 5. It's going to give me 55. And secondly, second fraction, what did we do to our denominator to get to the 20? This time we multiply by 4. So we better multiply the numerator by 4. It's going to give me 28. Okay, so we've now got 55 20ths, subtract 28 20ths, which becomes easy. It's 55 take away 28, it's 27 20ths. Okay, so our answer is 27 20ths, or we could now convert that. We could convert that back to a mixed number and give us 1 7 20ths. So both of those fine for the marks. Okay, number 2, change 2,500 cubic millimeters into cubic centimeters. So we might be thinking that, well, 1 centimeter is equal to 10 millimeters. Okay, and that's true. Okay, so we might be thinking that our conversion factor is 10. Maybe we just multiply or divide by 10. But we don't have centimeters, we have cubic centimeters. And we don't have millimeters, we have cubic millimeters. Okay, so this is really the linear scale factor. The linear scale factor is 10. Okay, we want the volume scale factor. And the volume scale factor, we need to cube that 10. Okay, we're going to do 10 cubed, which is 1,000. Alright, now if you've got no idea where that came from, we could think about why that is. So let's imagine a cube. Okay, this cube is 1 centimeter by 1 centimeter by 1 centimeter. Okay, it's 1 cubic centimeter, 1 by 1 by 1. Now we'll think of the same cube, and we'll label it up in millimeters. So we've now got 10 millimeters, because that's a centimeter. We've got 10 millimeters, because that's a centimeter. And in that direction, we've got 10 millimeters, because that's a centimeter. So they're both 1 cubic centimeter, but how many cubic millimeters is this one? Well, we have to do 10 times 10 times 10, which gives us 1,000 cubic millimeters. So we're saying that in 1 cubic centimeter, there are 1,000 cubic millimeters. So again, we've got our volume scale factor is 1,000. Okay, so now all we need to do is take our 2,500, was it 2,500? And we want to convert it to centimeters cubed, which is the bigger unit, so we'll divide by 1,000, which gives us 2.5. 2.5 cubic centimeters. 2.5 cubic centimeters. Okay, number 3, my cat catches mice and rabbits. Last year the ratio of mice to rabbits caught was 7 to 2. So 7 to 2 is mice to rabbits. And we want to know how many rabbits when he caught 84 mice. Okay, so if we do 84 divided by 7, which I think is 12, that tells us we've got 12 times as many mice in the bottom ratio as in the top ratio. So, a bit like above, we better do the same thing to this. We must have 12 times as many rabbits in the bottom ratio, so we better do 12 times 2, which gives me 24. Get a red one back? No, it's not letting me do red. 24. Okay, so I think the answer is 24 rabbits. Okay, so look at the higher questions. Right, number 1 is the same as on foundation, so we've already done that one. Number 2, write 0.326 with 2 little dots as a fraction in its simplest form. Okay, so we've got a recurring symbol here, and we've got a recurring symbol here, so only the 2 and the 6 digits repeat. So if we wrote this number out, it would be something like 0.326262626. The 3 does not repeat, 3 doesn't recur. Okay, so we need some sort of trick to get rid of those recurring digits. So let's let x equal 0.326. And we need to find some multiples of x so that we get that 3 on the left hand side of the decimal point and the 26 as the recurring bit. So I'll show you what I mean. Right, if we have x equals 0.326, 10x would be useful, because 10x will be 10 times the 0.326, which is 3.26, with our little recurring dots there. So I've got just the digits that recur after the decimal point. We've got 26, 26, 26. Now we need to find another multiple of x that will give us exactly the same thing. So 100x will be no good, because if I try 100x, I'm going to get 32.6262, because the 26, 26, 26 keep recurring. So that's no good, because my digits after the decimal point are not 26, 26, 26. So that's no good. But 1000x might be good, because 1000x will give me 326.26. Then I get the 2, the 6. So I've got my 2 and my 6, the recurring digits after the decimal point again, which is brilliant, because we can now subtract our 10x from our 1000x and our 3.26 recurring bits from our 326.26 recurring bits. Okay, so what do I mean? Right, I mean 1000x subtract 10x, that's going to be 990x. And 326.262626 subtract 3.262626, all of those 26 digits will disappear. So we've really got 326 subtract 3, which is 323. So the trick is to get rid of those recurring digits and choose in the right values of x, or the right multiples of x rather. Is the tricky bit you need to spot. So what do we do now? Well, if we divide both sides by 990, we'll get this unusual fraction of 323 990ths. Okay, so is it in its simplest form? I think it is. If we think of the 323, it's obviously not divisible by 2. If we add up the 3, the 2 and the 3, we get 8. That's not divisible by 3, so it's not divisible by 6 or 9 either. Not divisible by 4, because the last 2 digits aren't. Certainly not divisible by 5. It's not divisible by 10. The denominator's divisible by 11, but the top's not, so I think we're good. It's in its simplest form. Okay, number 3. Prove algebraically that the sum of any two different odd numbers is an even number. Okay, so it's one of those proof ones that you need some starting points. You need to know that the sum of means added together. Two different, that's going to be important, different odd numbers. So how do we represent an odd number? Well, we could say that 2n is always even, so 2n plus 1 is always odd. Now if we need two different odd numbers, we can't say 2n plus 1 again. Okay, because that's exactly the same odd number. So we could just use a different variable. We could say 2l, 2m, 2a, 2x. I'll go for 2m. So 2m plus 1. That's a different odd number. So we've written an expression for our two different odd numbers. So an expression for the sum of those two different odd numbers will have to be 2n plus 1 plus 2m plus 1. Okay, and we can simplify that a little because we get 2n plus 2m plus 2. What are we going to do? Prove algebraically that the sum of any two different odd numbers is an even number. Well, if it's an even number, okay, it's got to be a multiple. Sorry, if it's an even number, we'll do our trick of getting a factor of 2 outside the bracket. Okay, so what can we do? We can say, well, this expression is the same as 2. We can take that factor outside the bracket, n plus m plus 1. So we've got some sort of expression here, n plus m plus 1. Okay, and whatever that is, okay, we've then got 2 outside the bracket. So this result of this expression here, okay, when we multiply it by 2, has to be an even number. Anything we double has got to be an even number. Okay, so the proof's all about getting this factor of 2 outside a bracket or something. So we're done. Okay, we've proved that the sum of these two different odd numbers, this one and this one, which are different because of the n and the m, we've added them together, and we've got this factor of 2 outside, which means the sum of those two numbers is an even number.